Okay, so for this formative, we're going to be performance indicators are going to be C2, interpret and explain results using scientific reasoning, and A3, analyze and evaluate information to make scientifically supported judgments. You can find this in our Google Classroom. And we're going to try to figure out how much work it takes to push your car. So like how much friction it's causing when parts move against each other. So like if I spin this wheel, it comes to a stop, and that's because the axle is rubbing against the axle casing, and that's bringing it to a stop. There's also air rushing by, slows it down. So the way we're going to figure out how much work it takes to push the car is we're going to look at the amount of energy that it has from speed at the start of its motion, and then we're going to see how far it goes with that energy, and we're going to use the equation for work, which is distance, force times distance is work. If we divide the work, which is going to be from the kinetic energy, by the distance it moves, we'll get the force that it takes to push it, or at least the average force. So the first thing we need to do is figure out how fast it's going. So what we're going to do is we're going to use the time it takes to go between two objects. Those are our gates. And that will be our gate space. We'll record a video so that we can look at the time from the frames, and the time that it reaches the second mark minus the time that it reaches the first mark will be the gate time, and the gate speed will be the gate space divided by the gate time. And then the travel space will be how far it moves, so that we'll use that to calculate the work. So if I have these two marks, I can measure the distance between the marks, and I want to be consistent, so I'll choose the start of each mark. That's where I'll measure from. So I'm going to measure from here to here. And I can look at that on the meter stick. From this point to this point, it looks like it's 26.8 centimeters, 268 millimeters. So my gate space is 268 millimeters. If I wanted to write that as meters, this first M here means divided by 1,000. So this is the same as dividing by 1,000. So if I want to convert that to meters, I just divide by 1,000 and we get 0.268 meters. All right, so then what we're going to do is you'll push the car, and you'll stop pushing it before it reaches the mark. So here I'm pushing it, and then it's going to cross over the marks. This will be like, I'll look for a frame where it reaches here. This will be my time 1, or this will be the time that it reaches this marker and the time it reaches the second marker, and then it's going to keep going some distance. So let's say I also need to decide where I'm going to measure it from. So to be consistent, I'll measure it from the front of the wheel. So if I'm searching through my camera footage, let's say that when it reaches here, I got a time that's, say, 1.28 seconds. And let's see, when it reaches here, I find the frame, and I got, so we'll say this is, I'll call this time 1, and time 0, let's say when it reached here, it was 1.14 seconds. What I would do to find the gate time is I would do 1.28 minus 1.14, and I would get 0.14 seconds. And so that's why I would put here is 0.14 seconds. And then my gate speed is going to be 0.268 meters divided by 0.14 seconds. So I'll get meters per second. Since my units are up here, I'll remove the units, but I do need to put this in meters. So I can't use 268, I'd use 0.268 because the unit here is meters, not millimeters. And then the travel space is wherever my car ends up. Let's say it ends up over here. What I would do is I'd measure this distance, this is 1 meter, and then I'll move the meter stick over there, and I'm measuring from the front of my car, so it looks like it's 1.31 meters. So I'll put travel distance 1.31. And again, meters is up here, so I can just leave. I don't need to put the unit because the unit is at the top. And then if I had any, this would be my trial 1. If I had any notes, I could put them here. For the next part, we're going to weigh it, and then we're going to use this speed that we get over here. We're going to square it, multiply it by its mass, divide it by 2 to figure out how much energy it had to start with. And then we're going to divide this travel space by, we're going to divide this energy by this travel space to get the average force. Thank you.